Okay, we have here today another integral from the University Math Society. This one was problem 244. We have the integral of x times arctan of x squared dx. Okay, the first thing I think of whenever I see arctan is we probably want to do integration by parts unless there's an obvious u substitution. So let's just get right to it. We're going to do integration by parts using the DI method or tabular integration. And we almost always want to differentiate arctan as we don't have a good way to integrate it. So we'll write this down. We'll have here arctan of x squared, and I'll just integrate the other part, which is x. So we'll go ahead and differentiate here. First, we'll use the power rule, and we'll get 2 arctan of x. Then chain rule on this is going to give me 1 over x squared plus 1. Take an integral over here of x, and we're just going to have x squared over 2. And so this is going to give me part of the solution right there. So I'll just write that down. We're going to have x squared over 2 arctan x squared. And then here, this piece is going to be an integral. Now, 2 times 2, those are going to cancel. And so we're left with, we're going to have x squared arctan in the numerator, and then we'll just have this x squared plus 1 over here. And so now I'm just going to want to focus on this integral, and we'll come back and plug it back in later. So we'll have to remember this other part to come back to it. So now just focusing on this integral, what I'm going to do is, let's just rewrite it. But what I want to do is I want to create cancellation because we've got x squared here and x squared plus 1 here. So what I'm going to do is kind of force an x squared plus 1 to happen there so I can cancel with what we have in the denominator. But of course, I don't want to change the integral. So if I'm going to add 1 here, I also need to subtract 1. So what I'll do is take this minus 1 and use it to create another integral, but I need to kind of keep track of everything. So for this other integral, we'll have this minus out front. We'll still have arctan in the numerator, and we'll still have this x squared plus 1 here. But then we can cancel the x squared plus 1, is the way we set it up. And then each of these are integrals we can do separately. Now for arctan, we're in the same situation we were in before. We want to use integration by parts on this. So I'm going to do the DI method on this really quick down here if I have space. We'll create a 1 out front there so we have 2 functions. We'll integrate the 1 and we'll just differentiate arctan. Derivative of arctan is going to give me 1 over x squared plus 1 again. Integral here is going to give me just x. So we'll have part of our solution right here. So we're going to have x arctan of x, and then we're going to have this integral, which is just x over x squared plus 1. So I can handle this with a quick u substitution. I'm going to make my u equal to the denominator. So we'll call our u equal to just x squared plus 1. Then du is going to be just 2x dx, which I forgot over here. But then if I just multiply by a 2 here and multiply by a half out front, we just multiply by 1, but we've set it up where our du is right here. So for just this integral over here of arctan, we're going to have x arctan of x minus 1/2, and this is just going to become natural log of our u value, which is going to be absolute value x squared plus 1. But because x squared plus 1 is always positive, I can remove this and just write this as parentheses here. So this right here is going to go with this integral here. The tricky thing with this problem is we end up with 3 or 4 different integrals, and it's just keeping track of everything that's confusing. Okay, so now at this point we're almost done with the integration. I just took this and we brought it down here, and here's our solution for the arctan over here. So now we just need to integrate arctan of x over x squared plus 1. I can do this with another u substitution. So let's see, I think I'll come up here. So we'll just say u is going to be equal to arctan of x. Then for our du value, taking the derivative here, this is going to give me 1 over x squared plus 1 dx, but that's exactly what we have right here. If you just draw in a 1 right here, you'll notice that this right here is our du. So when we make this substitution, what we end up with is just u du. But that's really easy with power rule. We'll just integrate that and we get u squared over 2. Back substitute because our u is arctan. So this is going to become arctan of x squared over 2. So we'll just take this piece now and plug it back in for this integral, and we can finish it off. Okay, now just a quick recap of what we did. Initially, we found this blue part, and then we have this integral in red here, which is this solution right here. So what I really need to do is just plug this back in and distribute in this minus sign in order to finish this off. So first we'll bring down this part that we have in blue, which is x squared over 2 arctan x all squared. Then we need to distribute the minus sign into everything here. So we'll have minus x arctan of x, minus times minus here gives me plus 1/2 natural log x squared plus 1. And then minus to the minus here gives me a plus arctan of x squared over 2. But now one quick simplification, we have arctan of x squared in these two terms here, so I can actually just combine these two. So to combine these two, what I can do is let's bring, because we have a 1/2 in common, so we'll bring 1/2 in front here, and then we have x squared of these in one of these, so I can write this here as just x squared plus 1. Just get rid of this one right here, add a plus c, and that's it. Okay, so we ended up having to do integration by parts multiple times, multiple integrals. We did 3 or 4 integrals, and we got kind of a long solution here, but it came out okay in the end. So we'll stop it there. Thanks everyone for watching. Have a good day.